Okay, so guys, we are going to learn a concept that this is not in your book. I want to stress that. We're talking about a couple laws that are going to be used for any type of triangle. Now, we've talked about right triangles. That's been our main focus. And we've talked about trig, sine, cosine, tangent. But what's kind of cool is this idea of sine and cosine can now be used for any right triangle or any triangle, not just right triangles, as long as you know and understand these laws.
So this is just taking trig just a little bit further.
Exactly.
Letting you guys see some really cool relationships because we love triangles and there are some really cool things.
Now, first thing to notice, and guys, we're going to just give you the laws. We're not going to have you explore them. There is a way to prove these laws, but we're just going to give them to you so you know what they are, and we're just going to talk about using them, okay? So the first one, this is the law of sines. And the reason why it's called the law of sines is because, notice, it only involves the sine ratio, okay? Now, notice that there is actually, they're saying the sine of A, so sine of some acute angle, possibly, could be a right angle, could be an obtuse angle now,
okay,
over A. Now, I want you to look at the picture, and I want you to notice the capital A stands for the
vertice.
Okay, more so, not just the vertice, the angle, okay?
Right,
You're talking about the angle, okay? So you're going to be either given that angle or going to find it. And notice the underneath, you have a lowercase a, which is actually representing a side.
Okay, so the side that's across from that angle
is going to be named with the lowercase letter.
Okay, that makes sense.
So like angle C is going to be across from the side C, which is lowercase c, angle B. So the way that you name, guys, and I know that I do this with my students, I'm sure Ms. Hoke does too, using capital versus lowercase does make a difference in math, okay?
Yes.
I know some of you like to write all in caps or stuff like that, but lowercase in this case is a side, uppercase is an angle. Okay?
Which really, those lowercase, think about it, it's just a variable. It's talking about a measurement.
Exactly.
Where the A is talking about the angle itself, or that vertex where that angle is happening.
Okay. Now, again, notice it's the opposite side kind of associated with the angle, kind of looking at that. Now, what really the law of sines is basically three ratios that are set equal to each other.
Okay. Well, so is it kind of like a proportion if I just took out a piece?
Exactly. So let's say I am only dealing with angle A, angle B, and side B. Then you have a proportion, right? Or you could be taking out this one and just deal with the ones with the B's, or take off the... So in the sense, you're just dealing with a proportion, okay? That's really essentially what this law of sines is, okay? Now, what I want you to keep in mind, and we're going to do an example in just a minute, is that you have to make sure you are given the right information to use the law of sines, because if you don't, then we're going to learn another law in just a minute.
Okay.
To use the law of sines, so let's just think about, you're going to use two of these ratios. So let's say I'm just focusing on these two, all right? I would have to know 3 of those 4 unknowns.
Right. Makes sense.
So what are some scenarios what I could give you?
So we could have 2 angles and one of their opposite sides.
And it has to be the opposite.
Right.
So one opposite side. Because if I gave you side C, well, that wouldn't help, because then you would still have 2 unknowns. Okay.
Or I could be given 2 sides and one opposite angle.
Now, one thing I want to stress is, though, if they give you 2 angles,
we really know the third
then
angle.
you technically know the third. So knowing opposite side is important for you to understand, but if I give you 2 angles, let's say I give you angle A and angle B, you could find angle C.
Right.
Okay.
That's true.
But you still need that opposite side, one of the opposite sides. Okay. So that's the thing I want you to keep in mind. A lot of this, guys, bottom line is knowing what you're substituting in, and also order of operations, okay, and solving an equation. That's really what we're solving, all right? Okay. So let's try it, okay, and I'm going to do this one with you. I have Ms. Hoke help me out. Notice that in the picture, and they already have the triangle drawn, they said find B and C.
Okay.
All right, so which one do you want to start finding first?
Oh, it doesn't really matter. Let's go with C because I have its opposite angle that I see already marked there.
I like that you saw that. So we have this angle here, and it's across from that side C. So if I'm using the law of sines, all right, I do have an angle, and I'm finding the side opposite. Now, do I have another angle?
Yeah.
Yes.
And I actually have its opposite
And I do
side
have,
too.
so I have 2 angles and I have one of the opposite sides. So if I was setting this up, I could say the sine of angle C is 41. And what would I put that over?
The actual side length of C, which we don't know what it is yet, so we're just going to call it C.
Equals, and what am I going to set it equal to?
The sine of 72, so the other angle that's marked there, and the side that it's across from it over 20.
And notice in that proportion, we only have one unknown.
Right.
So we can solve this. If I had 2 unknowns, we couldn't do it, okay? So this is just a matter of cross multiplying, okay? So we've done this before. That's one thing. The law of sines you should be definitely pretty comfortable with.
Yeah.
All right, so if I cross multiply, all right, I'm going to do the C times the sine of 72 equals, and what am I going to write on the other side?
20 times sine of 41.
Okay, and then what are we going to do?
Well, I want to get the C by itself, so I'm going to divide by sine of 72.
Now, this is where you have to be careful.
Yes.
It's that your calculator can be an excellent tool, but as long as you put it in right, okay, then it will be that great tool. So tell us how we're going to type this in.
Now, if this was me, what I would do is type in the whole numerator, 20 sine of 41.
Okay.
Because your calculator can handle all of that, but you're going to notice that after you type in the 41, right before you type in the 41, it starts a parenthesis that we would have to be really careful with closing if we try to keep this all in one big piece. What I would encourage you guys to do, type in 20 sine of 41, hit equals.
Okay.
And then just hit divide by sine of 72.
So when she did that, it gave us like 13 something. Don't write that down because we don't want to round unless we absolutely have to until the end.
Right.
And then like she said, just then put divide. So then it's going to say A and
Answer.
S, divide by. So you're taking that answer that you just got, divide by the sine of 72.
Right.
Now, if you want to close parentheses first and then divide by sine of 72, it still works, but
we've seen
people
too many
forget.
mistakes. We're trying to help
we're going
you.
to have to round, and I know the directions don't say round. We know with trig we typically round. So let's do the 10th. So what do we get?
10th place. So we're going to get 13.8 because it was 7.9, so we know that 9 is going to round it up. So 13.8 will approximately represent side C.
Okay.
All right, now to talk about side B, I know that I'm going to need to talk about the angle that's across from that also.
Anytime you're finding a side using the law of sines, you have to know the angle it's across. Okay? So can we find that angle?
Well, sure, because I know all of the angle measures of a triangle should add up to equal our 180. So 180 minus the 72 minus the 41 should give us 67.
All right. So to find this side, and I'm just going to kind of do some work down here. Didn't mean to put that right in the middle. I forgot we're doing something else. So how would I set this up?
Okay, so now I want to talk about the sine of 67. And then this over the side that's across from that is the B. And really here I could pick any other 2 sides because I do technically have the C, but C was rounded. So I don't really want to use my rounded answer if I don't have to. So let's go with the 72, sine of 72 over the 20 because those were given. Those were exact.
I love how you put that. We technically did find this. Unless we have to. If we have to use that rounded answer to find the next answer, which we've seen happen.
Sure, that's
But
okay.
this is one where we don't have to.
Right.
Okay?
And if you do by chance have to use that, please don't use the 13.8.
No.
Give yourself at least 4 decimals. Or just try to use that answer recall button when possible too.
All right, so we're going to go ahead and cross multiply again. So B times the sine of 72, and then 20 times the sine of 67, and then divide by
sine of 72.
Sine of 72. So notice it's very much kind of the same process as what we've been doing here.
Yeah.
So then B equals approximate, I should say.
Approximately. And again, I would encourage you guys to take 20 sine of 72, or sorry, 20 sine of 67. First, hit equals. That's going to give you the 18.4 something, etc. Don't write that down, but then hit divide by sine of 72. And that's going to give us about 19.4.
Okay. Okay, you get the idea?
All right.
All right, let's try another one.
Now notice this one. What do I not have here?
I don't have a picture.
But that's okay. We can draw it. And our pictures definitely don't have to be to scale, so I'm going to draw a triangle. And in my triangle, we talk about the measure of angle Q, so I know one of these vertices is going to be Q. That's what I'm going to find here. But then they give me a lowercase q. So where does that lowercase
that
q
should
have
go
to be?
directly across from it, opposite. So that'd be 27 right across from it.
Love it. And then r and the measure of angle r, the other two things that they give me, do you think it matters which vertex I label?
It's just a sketch.
Right, so it doesn't really matter. So I know that, let's call this side r is our 34, and the measure of angle r should be across from that lowercase r. Should be our 82. I'm sorry, 82. I'm just going to write an r here. I'm trying to do too many things at once in my head. Okay.
And notice, guys, they don't give you the vertex for the other angle or the other because we don't know it and we don't need to know it.
Exactly.
It doesn't matter, okay?
Not needed. Oops, okay. Moving on. We need to determine the measure of angle Q. So we're trying to find this measure right here.
Okay. So I have the side across from it.
We do.
So that's good. And I have another angle and the side across from it. So I can use a lot of signs.
We can.
So I can say, let's say the sine of Q, and it's capital Q, over 27, the side across from it, equals the sine of 82, which is your angle R, over its side across from it, which is 34. And again, the reason why I know that is because of the lower and the uppercase letters.
Right. And I love that you said this isn't needed. We don't really care about that. But when you're looking at these pieces, you're looking at the sides across from there. That's the important thing. You'll always see that same relationship each time. All right. So when I do a little cross multiplying here, you're going to get 34 sine of Q is equal to our 27 sine of 82. And to get the sine of Q stuff by itself, because I know I'm trying to isolate that variable, I'm going to have to divide by the
34. Now, some of you might, as she's writing this, some of you might already notice here that because we're finding an angle and a triangle, and I only know one of the angles, I'm going to have to use those inverse trig ideas. So to find angle Q, I'm just going to do the inverse sine of that, basically that ratio over off to the side. Now, I like that you just left it all as is. And we're going to talk about how we could type this in our calculator.
Yes.
Okay?
All right. So what do you want to tell them, Ms. Palermo?
So what I would do, and this is just depending on the person, okay? You could type all of this at once.
Yeah.
But the thing about that is calculating errors happen, especially with our calculator. So I would type what's in the parentheses first. So I would do 27 sine of 82. Now, you could, I'm comfortable with it only because I can close the parentheses and then go ahead and divide by 34.
Right.
Or you can push enter. It gives you about 27 something, 26 something.
Yeah.
And then divide that by 34. And that gives you about 0.7864.
Etc. Okay.
And I'm rounding to 4 decimal places because some of you guys, here's the deal, some of you aren't comfortable with doing it like this. So if you need to round and use that rounded answer, type it in again, you can, but you got to use 4 decimal places at least. At least.
And the best thing that we would encourage is if you can use that answer recall button, because that's going to give you the exact. So she's going to talk about that in a second.
So that value represents what's inside that parentheses.
Right.
Okay? So that represents all of that stuff. So I'm going to take the second sign button, so the inverse sign, and in parentheses I'm going to hit the second, the negative key, the answer recall button, and it's going to say inverse sign, and in parentheses it's going to say A and S. So they're saying take that 0.7864 and put it in replace of the parentheses. And I'm going to push enter, and it's going to tell me the angle measure for angle Q is about 51.8 degrees.
Okay. Now, if you are going to type that all in at once,
yes,
what I want you guys to realize is when you hit that inverse sign button, it starts a parenthesis. So we want to say everything inside of here, right? So we're going to start by typing in, obviously, the numerator, the 27 sine of 82, but you're going to notice after you hit sign, it starts a parenthesis. You have to close it. Then divide by 34.
And then when you push enter, it gives you the same answer.
Yes.
So you can do it. It's doable.
Oh, yeah. It's definitely doable. And one thing, though, that I want to just emphasize is if you have multiple things in the denominator and it's not just a single, number, sometimes it gets a little trickier, too. So just some multiple ways to at least check yourself. Okay.
All right.
Just start that.
Okay, so we are trying to find A in this case, okay? And notice they're giving you the angle across from it, but we don't know side A. they give you also two other sides. So what are your thoughts?
Okay, well, as I look at this one, I notice that we don't really have any opposites.
Yeah.
Like, usually I have to have something and it's like an angle in its opposite side or a side in its opposite angle. And they're both, they're unknowns. So I'm thinking we can't really use the law of sines here, can we?
We can't use the law of sines. And guys, if you find, all right, and because this is going to be the big trick. Law of lines.
Law of lines.
This is going to be the big trick, is that how do you know which law to use? And I like how you said it. You have to have some opposites here. And we kind of started today okay, we need two angles and one opposite side. Well, we only have one angle. So one opposite angle and two sides. But here's the deal. The angle that we have, we don't have the opposite side. Okay?
Right.
So we can't use the law of sines. So that means we're going to have to use a different law, which we're going to learn in just a minute. So hold that thought. Okay? Hold that thought. We'll come back to this. All right? So leave some space or whatever.
All right. Now, take a look at this one with me. What information are we given in this picture?
All three sides.
All three sides. Okay, so if we're given all three sides, can we find all the angle measures?
No. If we use the law of sines, now if we're using the law of sines, we needed at least one angle.
Right.
And I don't have that, so I'm thinking no law of sines again.
Man, it's kind of limiting, isn't it?
Yes.
And because it is limiting, we have another law that allows us to be able to look at some of these examples.
So guys, we're going to come back to these two examples eventually,
yes.
Okay?
So leave some room.
All right. So here's the deal. It says law of cosines. Now, this one has a lot more going on in it.
Yes.
But here's the deal. The reason why is because there's three different scenarios. You notice they all look very similar, all right? One thing I noticed is that it looks kind of like the Pythagorean theorem a little bit. It has that a squared and b squared and c squared. Mm-hmm. But depending on when it starts with, notice it says a squared equals, then the other two sides squared added together. Then it says minus 2.
And then the other two sides.
The BC. Now, the BC are the two sides and over here, not here. And then it says the cosine of A. This is why it's called the law of cosine. Notice the angle that you're dealing with in this one
is across
from that opposite side.
Okay.
So whatever I'm starting with, b squared, that's the angle I'm dealing with. And then the rest of the stuff fills it in.
Okay.
So it's not like there's three different laws in the law of cosines. It just depends on what you're dealing with. All right.
Okay.
So notice it says the length on the left side, so A, B, or C, is of the equal sign is opposite the angle used in the equation. So if we're given angle A, B, or C, then we're going to use that side as across here. Or if I'm finding that angle.
Right.
Now, the big question is, when would you use the law of cosine? So if you just look at one of them.
Okay. So it looks like I know I can't have lots of missing pieces. I either am looking for a side.
Okay.
When I'm given an angle that's across from it.
Okay. So we have to...
And the other two
We
sides.
have to basically be given... let's see. What do we have to... How we would word it?
We have to be given...
Included angle. So like the opposite angle.
Yeah. Opposite angle with the other two sides.
Is
that a good way to say
it? Two sides. Yeah.
Not the opposite side that we're looking for.
Because then we would be finding the opposite side.
Or if I was given all three sides, I could do an inverse cosine to be able to find the angle.
So like the last one we just looked at, if I give you all three sides, we can find any of the angles.
Yeah.
Okay. So that's kind of what we're going to be doing. So let's go back, and I'm going to backtrack to this one I kind of talked about, and then I'll have Ms. Hochgraby help you with the next one.
Sounds good.
All right. So we're going to find just side A. All right, and if we're going to find side A, we already determined can't use the law of sines. Now, notice what we're given. We're given the angle that it's across that we're finding, and we're given the other two sides. That was
nice.
One of the
That's
scenarios.
Exactly, yeah.
Okay, so how would I set this up? Well, since this is the side I am finding, and the angle I'm given, that's what I'm going to start with. So I'm going to start with a squared equals
our 3 squared plus 5 squared minus 2 times 3 times 5.
And I'm just going to put them in parentheses. You don't have to. You could just write, actually, you could just write it with the little dot.
We won't care, yeah.
Either way. And then
cosine of 61.
And then notice again, the reason why you had A here and 61 because of the fact that those are opposite.
Right.
All right, now this one, guys, I'm going to just stress. Law of cosine. So this is the law of cosines here. We couldn't use the law of sines. All of this is really order of operations.
Right.
Substituting and then order of operations.
Exactly. And honestly, guys, when you think about Pythagorean theorem being kind of the first part of that, from there it's just minus 2 times whatever the two kind of leg pieces that we used in a squared and b squared were, and then the cosine of that opposite angle. It's really not that scary once you get comfortable with using it.
It's kind of like when you do the distance formula. It looks kind of crazy. Now, what I tend to do, guys, and you guys can kind of do this.
What you tend to do?
What I tend to do, guys, is kind of do one piece at a time. This is one, actually, you could technically type this all in your calculator because there's no unknowns, all right? So it is doable. I tend to kind of do one thing at a time. So like 3 squared is 9, 5 squared is 25.
And you could even do that part at least all at once and say 34 if you wanted to.
So you could just say a squared is equal to 34. And then do this stuff over here. So 2 times 3 times 5, so that would be 30. Minus 30. Now, here's the reason why I want to stress this. If you're doing this, and I'm just going to jump right down here. This is where people make mistakes.
Yes.
You can't do 34 minus 30 and say 4 cosine of 61. Why not?
Order of operations.
This says multiply before we add or subtract.
Right.
So this is where, guys, I would, and I don't know if you agree if this, I would just type this in my calculator just like you see it. So do 34 minus 30 times the cosine of 61. And it's going to give you a nasty decimal, of course.
Yes.
So it's going to be
like
about
19.4557.
And it's going to keep going. Now, we want to keep that in our answer because we want to do now what now?
We want to take the square root to get rid of that square. So I'm going to take, in my calculator, I'm going to do the square root, and then I'm going to do the answer recall button. And that's going to give me 4.4. If we round to the 10th, we'll say 4.4.
Now, again, guys, if you're not comfortable with that answer recall, ask us tomorrow in class. Make sure you're good with that. And if you're still not good with it, then you're going to have to round quite a bit more because you don't want to round to the 10th and then round to the 10th again because you're going to be off.
That's going to be very off, yeah. So at least give us 4 decimal places until you get to your final answer if you don't use the answer recall button. All right, so on this next example, we already had determined that we cannot use the law of sines.
And the reason why was because we don't actually have any angles provided.
So we have no opposite parts.
And law of sines, you need at least one angle provided. Okay?
Exactly. So we can use law of cosine. I mentioned that we could do that when we've got 3 pieces, when we've got 3 sides, I should say. Get more specific. 3 sides. So we can do that to find angle measure. Now notice here we want to find the measure of angle D.
Okay.
Okay, so what side is opposite D?
The side that's 25.
25. So that's going to be the C in our formula, the C squared that we're going to use.
Okay.
Okay. So let's go ahead and, or in this case, D squared. Yeah. That we'll use.
It's what you're starting with.
Your starting piece. All right. So what are we going to write here?
25 squared equals, now what you got to remember, it's the other side squared added together. So it'd be like 18 squared and 8 squared added together. Then it's going to be your minus 2 times the other 2 sides, 18 and 8, then times the cosine of D, which is what we were trying to find.
And we're going to leave it as just D, because, yeah, like you said,
capital D as well.
Capital D, that's important. All right, now let's go ahead and let's do some calculations.
All right,
25
so
squared?
That's going to be 625. And then, guys, if you want to do 18 squared and 8 squared added together, that's going to be 388. And then minus, because I'm going to have that negative 2 times 18 times 8, that's going to be minus 288 cosine of D. Now, again, notice order of operations, all right? You squared those each individual, add them together, because you can do that, and then the other stuff you multiply together. Now, what about...
And I'm doing all that before any addition or subtraction.
Yeah. What about if I do 388 minus 288 and just call that 100?
Yeah, well, that seems like that'd be a great idea, except for then it doesn't follow order of operations.
And why is that?
Because we have multiplication that's going on when I take the negative 288 times the cosine of D. So I'd have to multiply these before I could add or subtract. So here's the thing. We want to get this cosine of D by itself.
Okay.
So we want to remove everything else from that side.
It's kind of like, in a sense, if you're solving an equation.
And this is like
if you had x. Yeah, if you had an x there, you can't combine those because they're not like terms.
Right.
Okay, so here's what I'm thinking. Let's subtract 388 on both sides. This will help isolate that cosine d, hopefully, eventually. So when I subtract that, I get 237 equals a negative 288 cosine d. And then I'm going to go ahead and divide each side by a negative 288. Kind of that inverse operations here, dividing that. So I'm going to have the cosine of d equals a negative 237 over 288. Now, here's the deal. I'm thinking back to what we just been doing with cosine, sine, tangent ratios. This cosine ratio technically is saying it's a negative ratio.
Yeah.
We've never actually seen that. Now,
we haven't. But, when we've talked about right triangles, we're always finding acute angle measures.
That's true.
Here, we don't know that this is a right triangle.
Oh, okay.
Let's find it and let's see what happens.
Okay, so to find angle D, I'm going to do the inverse cosine.
Let's do a measure of angle D equals.
Okay, so the inverse cosine of that negative 237 over 288. So when you type that in, that one's not hard. This one's actually a lot easier to type in. So the inverse cosine, and then I'm going to put negative 237 over 288. Push enter. Well, hold on a second. I put it in wrong. I put minus instead of negative. I apologize for that. So divided by 288, and that gets you, it's an obtuse angle. It's 145.4 degrees.
So here's the thing. So far, we've talked about only right triangles with trig. And with right triangles, the two angles that are not the right angles are both acute.
Okay.
And so we've never seen any negative ratios.
Okay.
When we're working with law of cosines, you're going to be able to find those obtuse angle measures as well. So when you do, if you notice that you're taking the inverse cosine of a negative ratio, that's just a good hint that it's going to be an obtuse angle.
Okay. Now, if I know that angle D, all right, I could use, and here's the deal, there's going to be question thinking more tomorrow. I could find the other two angles, not with that angle yet, but I could use the law of cosines again to find angle E. I could use the law of cosines again to find angle F. So if you know all three sides, you can find any three of those angles using the law of cosines.
Definitely.
That's what's really cool. All right, one more question. We're going to skip. Yep. Now, this one is another one. There's no picture. So let's draw a picture to kind of get a visual. And again, it's just a sketch. We don't know what kind of triangle it is. All right, so I'm going to draw a sketch here. And I do notice they said find angle Y. So I know one of them has to be angle Y. Given angle X, so let's say this is angle X. I'm going to call this 50. And then Z is 8. Now, what does that mean?
Well, if we have a side length of Z, we obviously across from that would have a vertex of Z.
Okay, so this other angle should be angle Z, and then the side across from it is 8. And again, notice that lowercase z is saying side length, and then they're saying the Y is 14, so that should be located across from angle Y. So this is the angle we're trying to find. This is our kind of our question mark. Now, think about, here's the deal. When these types of questions, all they're going to say is find a measure. They're not going to tell you which law to use. So let's determine what we do have and where we can go with this, okay?
Okay, so looking at this one, I noticed that I have an angle. I only have one angle. And I don't have the piece that's across from that, okay? And the angle that I'm looking for, I do have the piece that's across from that, but I need to have a set of opposites.
Okay.
So that's not really, can't use law of sines here.
Okay, so basically you eliminated, can't use the law of sines.
Which, now I'll tell you guys that if you can use it, that's a little bit easier one to use. So I look for that first.
Yeah, I like that you did that. And here's the deal, guys. Let's say you thought law of sines. So you could start and say, okay, well, the sine of y over 14 equals, well, the only other angle I have is the 50 sine of 50 over, well, I don't know the side across from it.
So we have two unknowns.
So we have two unknowns. So it's not going to be helpful, all right?
So let's think law of cosines. We have an angle measure.
Okay.
And what we're looking for is the side, or I can find the side across from that. I shouldn't say that's not really what I'm looking for yet. But I noticed that I do have the other two legs.
Okay.
Okay?
Yes.
Now, I can't go straight to talking about y here.
Okay.
Because even though I do have the 14, I would have two unknowns because then I'm also missing other legs. So to use the law of cosines, I either need to have all three legs or I need to have two legs.
Okay. Gotcha.
Okay? And I have to use the leg that's missing. That has to be that one that's opposite the angle.
And I love that. And here's the deal. She's basically saying we have to find this side. I'm just going to call it X, basically, before I can find that angle Y.
Right.
And guys, if you're not sure, I mean, do this. Just write down just think, okay, if I could use a law of sines, what would it look like? And if you see two unknowns, well, then we got to use the law of cosines, all right? So if we set up using the law of cosines, we have to find this first. So the first thing we're going to do.
And you're going to notice that because otherwise, if you tried to use that, like 14 squared equals 8 squared plus x squared, you're going to notice I've got two. I'm going to have an unknown there and an unknown for the angle.
Yes.
You have to only have one unknown.
So the first thing we're going to do is find x, and I labeled that here. This is x. So how would I set it up?
Okay, so I'm going to say that x squared is equal to our 8 squared plus 14 squared minus 2 times 8 times 14.
And again, you can do the parentheses like Miss Hochgravy did, or you can do the little dot.
We won't care.
It's the same.
Times cosine of 50.
Now, notice in this problem, how many unknowns do I have?
I only have one unknown.
And that's what we need, okay?
Yes.
So that's the first thing we're going to do. And this is one scenario where once we find x, we're going to kind of talk about basically what does that mean from here, okay? So we're going to find that. What do you think? Should we just type this whole thing in, or are we going to do one step at a time?
Well, if they type it all in all at once, that would be a good check to see if they can get the same thing we can get. So let's just go through each step.
Okay.
So if I did the 8 squared plus 14 squared, that's going to give us 260. And the negative 2 times 8 times 14 is going to give us a negative 224. And then I'm going to type in, I would do if this was me, I would do negative 224 cosine of 50, or just 224 cosine of 50, and then take 260 minus that. But you could really probably at this step
just type
it
260 minus 224 cosine 50. Because here's the deal, guys. Your calculator is programmed to do order of operations. So they're not going to do 260 minus 224
until it does the multiplication.
Because they're going to do that part first. So their calculator will do that. So you get x squared, if I can write this correctly. Now, this will give you a kind of a nasty decimal, but now this isn't the answer yet.
Right.
Because what do I have to do? So it's like, are we getting there?
I'm just making sure.
Yeah,
116.0155754, etc.
Okay.
Now, that's x squared.
Uh-huh.
So I'm going to be taking the square root of that answer. And I just did that in my calculator. I did square root and then that answer recall button.
Okay.
And I get 10.7711 if I round to 4 decimal places.
Now, and here's where it brings up a good conversation here. The fact that she gave me 4 decimal places, the reason why is because this isn't my final answer. I have to use this answer of x to find y.
Right.
Okay. So if you have to, we've been talking and preaching to you guys, don't use rounded answers to find other rounded answers unless you absolutely have to. Well, guys, this is the chance. We have to. Okay. So when you have to, let's leave it in 4 decimal form, because if you cut it off and say 10.8, you are going to be further away from what y could be. Okay. All right. So that's the first thing. Now, the second thing is now we're going to find
the measure of the angle.
So we're going to actually find the measure of angle y. Okay.
Now I'm thinking I can use law of sines because I now have 50 with its opposite, the 10.7711.
Ah.
And I have the 14, the side across from the angle y.
I love it.
So now let's use law of sines. It's a little bit easier to use when I've got the right pieces, and I've got all the right pieces.
So we're going to use law of sines. So this is one, guys, when you have to find something else, you can then go ahead and use law of sines for that next step. Okay, so let's use law of sines. How would we set it up?
So the sine of y over 14 is equal to the sine of 50 over our 10.7711.
Yeah, and keep that 4 decimal places so it's more accurate.
Right. So it's really 14 sine of, well, let's do 10.7711. I'll keep the variable on that side. Sine of y is equal to 14 sine of 50. And I'm going to be dividing both sides then by the 10.7711. Okay, now, here's what I would do in my calculator.
Okay.
To keep this as exact as possible. I still have that 10.771, etc. in my calculator. So I'm going to type in, now, if I'm going to do this, I got to be really careful. I'm going to type in that I'm going to take this 14 sine of 50 and divide that all by the 10 point, whatever the answer recall is. But when I type this in, I'm going to start with some parentheses. And I'm going to say 14 sine of 50. And I'm going to close those parentheses. And I'm going to have to use a double closing parenthesis to close the whole thing. Because I want to make sure that it's doing all of that and divide by and then use the answer recall. Now, technically, because it's going to do multiplication before it does division, my calculator is probably going to give me the right thing anyway. But I just want to point that out of kind of
and what she's saying, guys, is basically because if you type in 14 sine of 50 and then divided by that answer recall, they're going to multiply this first and then divide by, so you really don't need the parentheses.
It's not going to be a big deal, but I'm just going to, I know some of my students have been asking about the parentheses, and if I'm going to use them, I got to double close it.
Really, the time when you use parentheses is usually when you
in the denominator.
The numerator, it's not as big of a deal.
Right. Okay, so there I get like a 0.9956, etc.
Okay, let me write down just so we can kind of get an idea.
Yeah, so 0.9957 if we round appropriately. Okay, now that's the sine of y. So I'm going to do the inverse sine and do an answer recall. And I get 84 point, and how do we want to round? What do you think?
Let's do 1 decimal point.
So 84.7.
Sorry, guys. I'm running out of room.
So about 84.7 degrees.
Okay.
That is a lot to find one angle.
And guys, here's the deal. Here's the deal. This whole answer recall, and I know I've mentioned this to students before, and some students are really comfortable, some aren't. So, I know for myself, I don't want you stressing about it. So if you're not comfortable with it and you need to round, you got to round quite a bit. You have to have a lot of decimal places, okay? So if you have to put inverse sine of this, type it in again, you're going to be closer to this answer. That should be it.
And especially, and that's part of the reason we're rounding to the 10th place too. Is because if you round to the 10th place, we're going to get about the same answer.
Okay.